Hey calculus, we are going to practice the chain rule with exponential functions and log functions. Number 1, 7e to the negative 6x. Whenever you have an exponential function, whenever your variable x is in the exponent, the base is always your outer function. So 7 comes along for the ride, the outside function is e to something, and the inside function is negative 6x. All right, so the f prime of x, our derivative, the 7 comes along for the ride. The derivative of e to something is itself, e to something. So that right there is the derivative of the outer. The second step of the chain rule, we plug our inside function in as is, right there. So negative 6x goes right up there. That is the inner as is. And finally, the third step is we multiply everything by the derivative of the inner. So the derivative of negative 6x, using the power rule, would be times negative 6. That is the derivative of the inner. I would put parentheses around it so it doesn't look like subtraction. When we simplify this thing, remember, we multiply the numbers and put them out front. So we have a 7 and a negative 6. So that's going to give me negative 42 e to the negative 6x. That is our final best answer. Okay, the second one, we have 8 times e to the negative sine of x. So get in the habit of counting the functions. E is one function, negative sine of x is another function. It is an exponential function. That x, our variable, is in the exponent. So we have the outer function is e to something. So the 8 comes along for the ride. My outer function is e to something. Remember, if your variable x is up in the exponent, the base is always the outside function. All right, so the outside function is e to something, and your inside function is negative sine of x. So h prime of x, 8 comes along for the ride. The derivative of the outer, e to something, is e to something. So that is our derivative of the outer function, first step of the chain rule. Second step, we take that inner function as is and we plug it in inside that blank set of parentheses. So there is our second step, the inner function as is. And finally, the third step, we multiply everything by the derivative of the inner. So that negative 1 comes along for the ride. The derivative of the sine is the cosine. So that is the derivative of the inner function. There's all 3 steps. When we simplify, we must combine the numbers. 8 and negative 1 gives me a negative 8 out front when I multiply them. So we have a negative 8 cosine of x, and we also have an e to the negative sine of x. And there is our final answer. Okay, on to number 3. Let's count the functions first. We have cosine, we have e, and we have negative 0.5x. So 3 functions means this is a double chain. We are taking the cosine of e to the negative 0.5x. So the outermost of those 3 functions is the cosine. And don't forget, like I just did, don't forget the 6. But the cosine is the outermost. We're cosigning the other 2 functions. The inner as is always everything else, the other 2 functions. So that is e to the negative 0.5x. All right, we still have 2 functions here, so we go again. The outermost function there, of course, is e, because our exponent, our variable is in the exponent. That means the base is the outer function. So our outer function is e to something, and then my inner function is negative 0.5x. Okay, now remember, for a double chain, on the first chain we only do the first 2 steps. So y prime is going to be, the 6 comes along for the ride. The first step, the derivative of the outer, the derivative of cosine is negative sine of something. So that is my derivative of the outer. Second step, I plug the inner as is right inside that blank set of parentheses. So inside there is e to the negative 0.5x. So that is my first chain right there. Okay, that's my first 2 steps. At this point, after I do my first 2 steps, I start over and I go to the second chain. So right here, the derivative of the outer, the derivative of e to something is e to something. So that is my derivative of the outer on my second chain. Second step, I plug the inner as is right in there. So that goes right there, negative 0.5x. And remember, on the last chain, you take the last step. What is the derivative of the outer? The derivative of negative 0.5x, using the power rule, is just negative 0.5. So that is the derivative of the inner function on the last chain, and this whole thing is chain number 2. Okay, so that's a lot. This is hard. Now when we simplify, the numbers go out front. We have a 6, we have a negative 1, and we have a negative 0.5. So a negative and a negative gives us a positive, and 0.5, half of 6, gives us a 3 out front. All right, we still have an e, a plain old e to the negative 0.5x. And we still have a sine of e to the negative 0.5x. Okay, we cannot combine this e and this e because this e to the negative 0.5x is inside the sine, so it has to stay there. So there is my final simplified answer. All right, again, please try to go through this on your own. All right, let's keep going. Number 4, we only have 2 functions here. We have natural log and 4x, 2 functions, 1 chain. 9 comes along for the ride. We are taking the natural log of 4x, so ln is our outer function, 4x is my inner function. All right, so g prime of x, our derivative, 9 comes along for the ride. The derivative of ln x is 1 over x, and we write that as 1 over something. All right, so this right here, that whole fraction is the derivative of the outer. Second step, we take that inner function as is and we plug it right down in there. The inner as is always in the denominator when ln is your outer function. So that is my inner function as is. All right, finally the third step, I multiply everything by the derivative of the inner, and the derivative of 4x using the power rule is 4, and I'm going to make it a fraction. Make everything a fraction. All right, so this is my derivative of the inner function. Third step, so we have all 3 steps. All right, the 9 comes along for the ride. The derivative of the outer is 1 over something. The inner as is 4x. Down here in the denominator, the derivative of the inner is 4. All right, when we simplify our function, tops and bottoms. On top, we have 9 times 4. That gives us a 36. On the bottom, we just have 4x. Okay, when I simplify that fraction, right here, I'm going to highlight it, 36 over 4. That gives me a 9 over 1. And the x is still on the bottom. Okay, so the 2 ways I can write that would be 9 over x, or I could write it as 9x to the negative 1. So those are my 2 final best simplified answers right there. Okay, number 5, let's count our functions. We have ln and x to the 0.7. 2 functions, 1 chain. 1,000 comes along for the ride. I'm taking the natural log of x to the 0.7. So my outer function here is natural log, and my inner function is x to the 0.7. All right, so p prime, the derivative, 1,000 comes along for the ride. I'm going to make it a fraction. The derivative of ln is 1 over something. 1 over something. So that is my derivative of the outer function, first step. Second step, I plug the inner as is right down here. When ln is your outer function, the inner as is always down here in the denominator, x to the 0.7. Third step, we multiply everything by the derivative of the inner, and that's a power rule. The derivative of x to the 0.7 is going to be 0.7x to the negative 0.3. All right? If you go off to the side, if you take 0.7 and subtract off 1, that's how you get negative 0.3. So this right here is my derivative of the inner. All right, so let's go through it again. The 1,000 comes along for the ride. This whole thing right here, I'm going to put a kind of a dotted box around it. That's my derivative of the outer, 1 over something. This right here is my inner as is. If it helps, label the parts. That's the inner as is. And finally, the derivative of the inner. And I made everything a fraction. Now if I multiply across the tops, I have 1,000 times 0.7 x to the negative 0.3. So that is going to give me 700 x to the negative 0.3. When I multiply the bottoms, I just have x to the 0.7. Okay, to simplify that, I can simplify these two x's right here. I'm dividing two exponents, negative 0.3 and 0.7, that have the same base x. So I subtract. Remember that dividing exponents rule? So that gives me 700 x to the negative 0.3 minus 0.7, which gives me 700x to the negative 1. And that is our final answer. That's as far as you can go. Look at how simplified that gets. Okay, always get in the habit of counting the functions right off the bat. We've got natural log, we've got sine, and we've got 0.2x. 3 functions, 2 chains. This is a double chain. We are taking the natural log of the sine of 0.2x. So this function is what's doing something to the other 2. So here 11 comes along for the ride, and my outside function is ln. My inner function is everything else, sine of 0.2x. Okay, I still have 2 functions here, so I know there to go again. My outer function here is the sine. I'm taking the sine of 0.2x. And my inner function is the linear function, 0.2x. All right, so now we get busy. Y prime. 11 comes along for the ride. Remember, on this first chain, we only do the first 2 steps. So the derivative of ln is 1 over something. All right, so I'm going to make that 11 over 1 a fraction. So that whole thing right here, that's the first step in the chain rule on my first chain, the derivative of the outer. Second step, I plug this whole inner thing in right here. So see if I can squeeze this in, sine of 0.2x. All right, so that is my inner function as is. At this point, I start over and I go to my second chain. This is the last chain, so I do all 3 steps. Okay, so it looks like this. The derivative of the outer here is cosine of something. And I'm going to put that over 1. So this is the derivative of the outer. All right, second step, the inner as is goes right here. 0.2x. All right, and finally, on the last chain, I take the last step. I need the derivative of the inner. The derivative of this inner is 0.2. And I put it over 1. Oops, just 0.2. Typo. 0.2. Okay, so that is the derivative of the inner. All right, so I'm going to kind of outline this. This right here is the first chain, first 2 steps. All right, derivative of the outer, 1 over something, inner as is, sine of 0.2x. Now I start over. This whole thing here is the entire second chain, all 3 steps. Derivative of the outer, cosine of something, the inner as is, 0.2x, and the derivative of the inner, 0.2. All right, now the fun part, algebra. We simplify. Just multiply tops and bottoms. On top, we have 11 times cosine of 0.2x times 0.2. So that gives us 2.2 times the cosine of 0.2x. I multiplied the tops. Now when I multiply the bottoms, the only thing down here is sine of 0.2x. Okay, so there's our answer. We could also simplify that because we know cosine over sine is the same as the cotangent. So we could write it as, oops, highlighter mode. We could write it as 2.2 times the cotangent of 0.2x. So there are my possible answers. If you get this far right here, I am thrilled, especially in distance learning. You could also take it one step further. This is acceptable too. All right. This concludes the video for the first side of this worksheet, and there will be a video for problems on the second page of the worksheet, 7 through 13. So you go to that video next if you need it.